Hi everyone and welcome to today's Saturday session with ExamRevision. We're going to look at coordinate geometry of the line and we're going to look at exam questions from the 2023 paper, 2022 paper and the SEC sample paper. So before we start into some exam questions, let's just take a look at some important formulas we have on the coordinate geometry course on page 18 of our formula booklet. So in the junior cycle course, you should be well aware of the slope of a line, the length of a line, the midpoint of a line, and the equation of the line formulas in your formula booklet. Now, it's a really good idea to open up this page when you see a coordinate geometry question in your exam, because a lot of marks are going for just simply writing down the formula. So if we take a look at our diagram up here, we can see a lot of important points that will help us figure out what to use in our formula. We have the point P, which contains x1, y1. So x1 correlates to where it falls on the x-axis, and y1 correlates to where it falls on the y-axis. Likewise with point Q, it's the point x2, y2. x2 again correlation to where it falls on the x-axis, and y2 correlation to where it falls on the y-axis. So it's very important to remember, just like in our alphabet, x comes before y. So when writing down any point, we always look at where it falls on the x-axis first and then where it falls on the y-axis. The last important part in our diagram is this point up here, which represents 0C. That is the point where the line crosses the y-axis, and that comes into play in one of our formulas later on, which I will talk about. Okay, so our first formula on this page is the slope of a line formula. The slope talks about the gradient of the line. So is the line increasing or decreasing? So if it was increasing, when we look at the graph from left to right, we would see the line increasing up. If it is decreasing, it would be going down as we look from left to right, just like what's happening here from P to Q. The letter M is used for the slope of a line. And in this formula, we can see that we use y2 minus y1 over x2 minus x1. So therefore, to use this formula, we need to know 2 points on the line if we want to find out what the slope of this line is. Our second formula, the length of a line, also can be written as PQ, or whatever letters you're talking about, or coordinates you want to find the distance between, with 2 lines at either side. That is another way that they can ask this question. In this formula, we're trying to find the square root of bracket x2 minus x1, close bracket to be squared, plus bracket y2 minus y1, close bracket to be squared. So again, in this formula, we need to have the 2 points that we want to find the distance between. Our third formula, the midpoint of a line, allows us to find the center or the halfway coordinate between 2 points. In this formula, we are doing bracket x1 plus x2 all over 2, comma y1 plus y2 over 2, close bracket. This is going to give us a coordinate, and that's why we can see that this formula is written like a coordinate with 2 brackets on either side and a comma in between. And our final formula on this page is the equation of a line. Now you can see there is 2 formulas here. The first formula, which is this formula here, y minus y1 equals m bracket x minus x1, allows us to create an equation of any line if we know 1 point on the line, which we will substitute in for x1, y1, and if we know the slope of the line. And we can see that the slope is m there, and we talked about that earlier, that m represents the slope. The second equation of a line formula allows us to figure out what the slope of a line is, or what its y-intercept is, if we already have the equation of the line. So you would not use this formula to build an equation of a line. You would use this formula if you have the equation of the line and you want to find the slope, or you want to find the y-intercept. And if we want to do that, we must get the equation of the line in this exact format, where y is the only thing on the left-hand side of the equation. Okay, let's start looking at some exam paper questions. So this question from 2023 says, A, B, C and D are 4 points on the coordinate plane. The points A and B are shown on the coordinate diagram below. Plot and label the points C, which is 8, 4, and D, 3, 6, on the same coordinate diagram. So this question has asked us to plot and to label the points C, which is 8, 4, and D, which is 3, 6. So from what we said before, when we look at the point C, X comes before Y. So on the X-axis, we're going to plot 8. And on the Y-axis, we're going to plot from 4. And there's my point C. So we're going to label a circle and then label point C. Next then we have point D. Again, point D is on the X-axis at 3 and on the Y-axis at 6. So going from the X-axis at 3 and from the Y-axis at 6, we get our point D. So I'm going to plot it first and then label it D. Now, in your exam, you don't have to plot those lines there that I did from the X and the Y axis, but that's just there to show you where I'm getting those points. The second part of this question says, write the coordinates of the points A and B in the spaces below. The coordinates of points C and D are already given. So this time we're doing the opposite of what we've done in part 1. We're looking at the points A and B and we're going to say where do they fall on the X-axis and on the Y-axis and write those coordinates. So again, looking at the X-axis first for point A, it lies at 1. And looking at the Y-axis for A, it lies at 1 as well. So the coordinates of point A is the point 1, 1. Once again, we'll do the same thing for B. So we will look to see where does B fall on the X-axis. So it falls at 6. And on the Y-axis, it falls on the negative side of the Y-axis, -1, giving us the point B, 6, -1. So after we've finished that part of the question, we now know where all our coordinates lie on the coordinate plane, and we also know what all the coordinates are for each point. Moving on to part B of this question. Paulina wants to prove that ABCD is actually a square. Answer B part 1 and B part 2 below to show that ABCD is a square. In part 1, they ask us to show that AB, and remember I told you from your formula booklet, that means the distance between AB is equals to the distance of BC. This means that we are going to show that the length going from the coordinate A to B is the same as the length going from coordinate B to C, which would help us prove that this is a square as all sides of a square are equal in length. So to start off this question, the first thing I would do is write down what my distance formula is for my formula booklet to pick up those easy marks. So that formula is the square root of bracket x2 minus x1 close bracket to be squared plus bracket y2 minus y1 all to be squared. Now we will have to use this formula twice, firstly showing the distance between A and B. So first, my coordinate for A was the point 1, 1, and the coordinates for B was 6, -1. And using my formula, I'm going to have to label these, which is my x1, my x2, my y2, and my y1. So to begin by doing this, I'm going to label that in my coordinate A, the 1 here is on the x-axis, and the 1 here is on the y-axis. And in my coordinate B, the 6 is on the x-axis, and the -1 is on the y-axis. Now you need to label which point will be the first point and which will be the second. This doesn't make any difference. So I'm going to choose A to be my first point. So I will change this to x1, y1. And B to be my second point. So this will be x2, y2. Now I'm ready to begin fitting these into my formula. Fitting these into the formula, I like to use empty brackets so I can substitute in the correct terms for them. So I'm going to write my formula again. But this time, instead of using x2, x1, y2, y1, I'm going to put in empty brackets. So keeping the formula exactly as it appears in our formula booklet, I have a bracket first, then I have x2, which I will put an empty bracket in, a minus comes next, then x1, so I will input an empty bracket, and then close my bracket from the formula, and the square goes outside. Continuing on with that, I've plus next, then a bracket, then an empty bracket for y2, minus an empty bracket for y1, and then my bracket again outside, and the square then from my formula. Now I can input the correct numbers for each one. So x2 was my first empty bracket, which was 6. x1 was my next empty bracket, which is 1. y2 was my next empty bracket, which is minus 1. And finally then y1 was my last empty bracket, which was 1. If you have your empty brackets done correctly, you could now input this into your calculator and you would get the distance between point A and B. Instead of using my calculator, I'm going to do this out manually. So I'm going to use the operations of BEMDAS, which says I should do what's inside the brackets first. So I'm going to complete 6 minus 1 first and minus 1 secondly. So I'm going to keep my square root. I'm not ready to do that yet. 6 minus 1 I know is 5, and that has to be raised to the power of 2. And the plus in between, and minus 1 gives me minus 2 to be squared. Now I can do my squares. So 5 to be squared gives me 25, and minus 2 to be squared gives me plus 4. And finally, 25 plus 4 gives me the square root of 29. Now, if you put the square root of 29 into your calculator will more than likely give you back the square root of 29. So if that does not simplify into a whole number, it's okay to keep it in this third form. Moving on to the second part of the question, I now need to show the distance between B and C. And hopefully I will get out the square root of 29 again, which helps me show that this is a square. So again, I'm going to rewrite what my coordinates are that I'm doing. So I'm starting off with B, which is the coordinate 6 minus 1. And then coordinates of C, which is 8, 4. And just like what I did before, I'm going to label them, which is the x coordinate and which is the y coordinate. So 6 is an x coordinate, minus 1 is a y, 8 is an x coordinate, and 4 is a y coordinate. Again, decide which you want to use as your first and your second point. That doesn't make a difference. So I will pick B to be my first coordinate and C to be my second. And again, I'm going to open up my formula with empty brackets. So we have bracket, empty bracket for x2 minus empty bracket for x1, close my bracket with the square, plus bracket, empty bracket for y2, minus empty bracket for y1, and the square goes outside. Now I can fill in my x2 variable here was 8, my x1 was 6, my y2 was 4, and my y1 was minus 1. And again, using BIMDAS, I'm going to do what's inside the brackets first. So square root again, 8 minus 6 gives me 2, which has to be squared. And 4 minus 1 turns into 4 plus 1, which will give me 5 to be squared. Now I can do the indices. So 2 to be squared gives me 4, and 5 to be squared gives me 25. And adding those two terms together, 4 plus 25 gives me the square root of 29, which shows that the distance between A and B is the exact same as the distance between B and C. So I have now completed part 1 of the question. The second part of this question asks us to, without measuring the diagram, show that AB is perpendicular to BC. So they don't want you to get your protractor out and measure the angle in between the line AB and BC, which if it was perpendicular should be 90 degrees. They want you to use coordinate geometry to show that they are perpendicular to each other. When they talk about perpendicular or parallel lines in coordinate geometry, they want you to talk about their slopes. If a line is perpendicular to another line, its slope should be its negative reciprocal of each other. That means that if one slope is a half, its perpendicular slope would be minus 2 over 1. So the fractions here of the slopes have been inverted and they both have different signs. One has a positive slope and one has a negative slope. So in this question, we're going to use our slope formula. So again, the first thing I'm going to write to get my marks is what my slope formula is. And that is m is equals to y2 minus y1 over x2 minus x1. And just like part 1, I'm going to do this twice. First, I'm going to find the slope of the line AB, and then I'm going to find the slope of the line BC. And if they are perpendicular to each other, they should have the negative reciprocals of each other. So starting off with the line AB, I know my point A is the point 1, 1, and the point B has coordinates 6, minus 1. And just like what I did before, I'm going to label which one is the x coordinate and the y coordinate. And again, which will be my first point and which will be my second point. Then using the empty brackets in my formula, I'm going to say m is equals to empty bracket for y2 minus empty bracket for y1. All over empty bracket for x2 minus the empty bracket for x1. Substituting in the correct values then into the formula, my first empty bracket was y2, which is minus 1. My second empty bracket on the top line there is y1, which is 1. Moving to the denominator of the fraction then, my empty bracket for x2 will be filled with 6, and my final empty bracket for x1 will be filled with 1. Now simplifying out that fraction, on the top line I have minus 1, which will become minus 2, and on the bottom I have 6 minus 1, which will be 5. So the slope of the line AB is minus 2 over 5. Therefore, if these lines are perpendicular to each other, the slope of the line BC should be positive 5 over 2. So again, I'm going to do the same thing again and check out, does that work out for me? I'm going to write my coordinates of the line I want to find the slope of. So that's B, which is 6 minus 1, and point C, which was the point 8, 4. Labelling those points again, 6 is my x coordinate, minus 1 is my y coordinate of B, and likewise in C, 8 is my x coordinate and 4 is my y coordinate. I'll put B as my first point and C as my second point. And just like on the left hand side, I'm going to fill in my formula with empty brackets first. Inputting in those values then, y2 was 4 and y1 was minus 1. x2 was 8 and x1 was 6. And simplifying out that fraction, on top there I have 4 minus 1, which will become 4 plus 1, which is 5. And on the bottom line, 8 minus 6 will become 2. And now I can see that they are the negative reciprocals of each other. My first slope was minus 2 over 5. My second slope was 5 over 2. So that indicates that the line AB is indeed perpendicular to BC. The second exam question we're going to look at is from the 2022 paper. So this question starts off very similar to how the 2023 paper started, asking us to write down the coordinates of a point on the coordinate plane. So it says the coordinate diagram below shows part of the N22 road in County Cork. 2 points on the road, P and Q, are marked on the diagram. The point Q has the coordinates 6, 2. Write down the coordinates of point P. So if we look at the coordinates of Q first, the coordinates they've given us in the question, we can see that indeed Q is at 6 on the x-axis and Q is at 2 on the y-axis. So doing the exact same thing for P there, we can see that P on the x-axis is at the negative side of it at minus 1, and on the y-axis it's at the positive side at 3, giving us the answer that P has the coordinates minus 1, 3. Part B of this question gives us the equation of the line PQ. It tells us that that equation of the line is x plus 7y equals 20. Using this or otherwise, find the coordinates of the point where the line PQ crosses the y-axis. So they want us to find out what is the y-intercept here. Now, the easiest way to do this would be to rewrite your equation of the line into the format of y equals mx plus c. That was the formula that was in our formula booklet earlier, where I told you if you are given the equation of the line and you can write your equation of the line in this format, then you can find the slope, which is m, and the y-intercept, which would be the plus c. So before we begin writing our equation of the line in this format, there is some easy marks that you can pick up. If we know what happens when a line crosses the y-axis, we can look at our x and our y-axis. So when any line crosses the y-axis, we know that x must be 0 because that point is going to be on the y-axis, which means the corresponding x value must be 0. So you can get marks straight away from knowing that when a point crosses the y-axis, the x value of the point must be 0. Likewise, if they asked us to find where a line crosses the x-axis, we would know that that would correspond to the y value being 0. So we've already picked up some marks here before we even find the full coordinate. Now if I rewrite my equation of the line x plus 7y equals to 20 in the format of that formula y equals mx plus c, I want to remove everything from the left hand side of my equation and only have y there. So using my rules of algebra, I can begin by moving some things over. The x is not needed on the left hand side, so I can remove the x from the left hand side. To do this, I'm going to balance the equation. I'm going to take away x from the left hand side to remove it, but I must do the same to the right hand side, so I'm going to minus x over there too. That will now give me the equation 7y equals minus x plus 20. So I'm putting the minus x before the plus 20 just to keep it in that format of y equals mx plus c. The next thing I need to remove from the left hand side of the equation is the 7 that's attached onto the y. So 7y means 7 multiplied by y. So to remove that 7, I need to divide by 7. So I'm going to divide by 7 on the left hand side, but that means I need to divide everything by 7 also on the right hand side. So I'm dividing minus x by 7 and plus 20 by 7 as well. That means that I will finally have y by itself on the left hand side, and that will be equal to minus x over 7 plus 20 over 7. Now I have the rest of my coordinate for where this line crosses the y-axis, and that is where my c value is plus 20 over 7. So the answer to this coordinate is the point 0 and then plus 20 over 7. Okay, so just looking at the marking scheme for this question here, we can see that this was worth a total of 10 marks. They included part A and B together. So you can see that the marking scheme is kind of mixed up regards to whether you got some of part A or some of part B correct, or one part right and one part incorrect. So we have two merits here. You've got low or high. So for a low partial credit, you were getting 4 marks, and then for a high partial credit, you were getting 7 marks. Okay. And then the 0 marks then if you didn't make any attempt or you didn't really produce anything that was worth a low partial credit mark. So what were they giving low partial credit marks? So in part A, if you had one of the coordinates correct, maybe the x or the y coordinate correct, or maybe you had written them the wrong way around. Okay, so really important to make sure you're looking, are you doing the x before the y-axis? And then in part B, they were saying if you were able to indicate that you knew x was equal to 0 when the line crosses the y-axis, that was going to give you some low marks. Well, 4 out of 10, really, that's a pass mark when you think about it. So very easy to get up to that mark. High partial credit then, if you had part A correct and you were able to make a really good attempt at part B, and then if you were able to find 20 over 7, but maybe you didn't write it as a coordinate, so you didn't put the 0 as the x value in the coordinate. So again, if they do ask you in the question to write the coordinates, make sure that you're writing the coordinates. You have the x and the y coordinate written as a point, just as they have here. Okay, they will take marks off that. Maybe if you said earlier x was equal to 0 and you said y was equal to 20 over 7, but you didn't write it as a coordinate, they can take marks off you for stuff like that. So just be really careful that if they say coordinates, you give it in that form. Okay, the last part of this question says a new road is being built through the point Q, 6, 2. On the coordinate diagram, it will be a straight line segment which is perpendicular to PQ. Work out the equation of this new road and give your answer in the form ax plus by plus c equals to 0, where a, b and c are real numbers. So they've given you a few important points here. They've given us the point that's on the line. That will be important when we go to use our formula. So we need q, which is 6, 2. And the second piece of information they said is this line will be perpendicular to the line PQ. If we want to make an equation of the line, we need to have a point on the line and we need to have the slope of the line as well. We already have the point, so now we need to figure out what is the slope. In the previous question, we rewrote the equation of the line for PQ in the format y equals mx plus c. So we already figured out what the slope of the line PQ was when we wrote the equation of the line in this format. That was whatever value m was. So rewriting that equation of the line from part B, it was y equals minus x over 7 plus 20 over 7. So what is my value for m in this equation of the line? Well, we can rewrite minus x over 7 as minus 1 over 7x plus 20 over 7. That indicates that m is equals to minus 1 over 7. So the slope of PQ is minus 1 over 7, but the slope that we need for our equation of the new road is going to be the negative reciprocal of this, as it is perpendicular to PQ. That means the slope that I need for this new road is going to be the inverted fraction, so 7 over 1, and the opposite sign, which will be plus. So our perpendicular slope is 7. Now I have a point on the line and the slope on the line for the new road. Therefore, I can now create the equation of the line. I am now going to use the other formula for the equation of the line in our formula booklet. That is the formula that allows us to create any equation of a line if we have a point and a slope on the line. And that formula is y minus y1 equals m bracket x minus x1. In this formula, I need to input my point x1, y1 and my slope m. The point on the line is 6, 2. And the slope of the line is 7. So labelling those, the 6 is the x coordinate and the 2 is the y coordinate. I only need one point here, so it is my first point x1, y1, and 7 is going to be my slope m. Now inputting those into my formula, I'm going to use my empty brackets first. Y minus empty bracket for y1 equals empty bracket for m bracket x minus empty bracket for x1. And inputting in the correct values, y1 was 2, m was 7, and x1 was 6. Tidying up this equation, y minus bracket 2 will just become y minus 2. On the right hand side, I need to multiply 7 into everything here. So it will be 7 times x, which is 7x, and 7 times minus 6, which is minus 42. Now, the question asks me to write the equation in the format ax plus by plus c equals 0. That means I need to move everything over to the left-hand side and only have equals to 0 on the right-hand side. So again, I'm going to balance my equation to move everything over to the left-hand side. Firstly, moving the 7x and the minus 42 over. I'm going to take away 7x from the right-hand side, which means I must take it away from the left-hand side. And also I'm going to add 42 on the right-hand side, which means I must add it on the left-hand side. Tidying up, that will cancel out my right-hand side completely. 7x minus 7x is 0 and minus 42 plus 42 is 0, which means I will be left with 0 on the right-hand side. On the left-hand side, I now have minus 7x plus y minus 2 plus 42 equals 0. Tidying up the equation as much as I can add the like terms minus 2 plus 42. That will give me minus 7x plus y plus 40 equals to 0. Now that is in the form ax plus by plus c equals to 0, but if we want to tidy it up and have a positive coefficient at the very start there with x, I can multiply the entire line by minus 1. When I multiply the entire line by minus 1, that will give me 7x minus y minus 40 equals to 0, which will give me the equation of the line with point Q 62 and the slope 7, which is perpendicular to the line PQ, which gives me the equation of the line of the new road that will be built. Okay, again looking at the marking scheme here again for this question. This question was only worth 5 marks, so particularly a lot of work just for 5 marks when you compare it to part A and B was worth 10 marks together and probably a lot easier to do than this. So again, they've split this up into low, mid and partial credit. So low credit was giving you 2 marks. Your mid partial credit was giving you 3, and then finally your high partial credit was giving you 4 marks. And they've broken this up into how you would go about solving it. So they've got 3 steps here. Step 1 is that you would find the slope of PQ. Then you would go about finding the perpendicular slope. So we had to find the slope of PQ first, then the perpendicular slope. So if you'd got that far, you kind of had 3 out of 5 marks. You'd a lot of the marks gained. And then to move up to the high partial credit, they wanted you to have the equation of the line formula and that you started substituting into it then. And then step 4 then that you were to rewrite it in the correct form, ax plus by plus c equals 0. So again, the low partial, doing anything kind of good to try and get yourself started. Mid partial, you had 2 of those steps correct, and high partial, you had 3 of those steps correct. As I mentioned in the previous page, I said it doesn't really make a difference if you had your answers minus 7x plus y plus 40 equals 0 or 7x minus y minus 40 equals 0. Both of those are the exact same equation, so it doesn't make any difference. What did make a difference if you were to give these without the equals to 0. So you're taking 1 mark away from you if you didn't write it as an equation and you didn't put it equal to 0. So again, kind of silly marks to be given away there at the very end of the question if you'd everything else done. Make sure you're writing it in the correct form. They really wanted you to write it as ax plus by plus c equals 0. They mentioned that in the question, so they expect you to give it in that form. So the next question on the 2022 paper tells us that the line H has a slope of 4 and passes through the point 2012. It gives us a diagram of the coordinate plane, and we can see the line H there with the point 2012 included in it. It then asks us to find the coordinates of another point on the line H other than the point given to us in the question. Now, the fact that they give us the point on the line and they give us the slope means that we could use our equation of the line formula to create the equation of the line for H. Once we get the equation of the line, we could sub in any x value and see what the corresponding y value is for that. But there's actually a quicker way to do this. Given that we know our slope is 4, another way of finding the slope is using the rise over the run. That means that the rise over the run is equals to 4 in this case. Another way of writing 4 would be 4 over 1. That means that as the line is moving, it rises up 4 for every 1 that it moves over on the x-axis. That means that if we run over 1 on the x-axis, we would have to move up 4 units as we rise. And that would give us another point on the line. So to find this point that I've highlighted here, I'm going to add 1 onto 20, which means the point will be 21 on the x-axis. And I'm going to move up 4 units on the y-axis. So I was at 12 on the y-axis, and 4 up from 12 gives me 16. So that is the y value of this point. So another point on this line H is the point 21, 16. Now there's several different answers that you could get for this question. We could continue on with this slope of a rise of 4 and a run of 1, again from this point, and that will give us another point on the line. So running over 1 and rising 4 would give me another point here that would be 22, 20. So either of these answers would be correct for this question. They're both points on the line H. There's an infinite number of answers that you could give for this. So I'm going to pop down 21, 16 is another point on the line. Okay, again, looking at the marking scheme for this question, you can see if you look on the left hand side, you've got multiple different ways of doing this. You can see all the different ways that they're accepting this question done. So lots of different ways that you could have done it. And as I told you, there's lots of different answers you could have given for this as well. Not all of them are going to be there now, as you can see, but you could have done it multiple different ways and got multiple different answers. I chose to do it the very first way there by finding out my slope as a rise over run and then adding on that to my x and y axis to get my new coordinate on that line. But just have a look at the other ways there. Maybe you would have done it a different way yourself. I thought that was probably the easiest way to do it and the quickest way to get the answer. Again, looking at the marking scheme then on the right hand side, we can see that this was out of 5. And we had low and high partial credit for that. So for your low partial, you were going to get 2 marks out of 5 for this. And for your high partial, you were going to get 3 marks out of this. So for low partial credit, they kind of said if you're able to say the slope is equal to the rise over the run, it's the formula we should know as well to find our slope, or any indication that you kind of need to know the slope to find this. So if you're able to write something about the slope, saying that that was kind of going to be the same throughout the equation, you would have got your 2 marks for that there. Then for the high partial credit, depending on what method you did there, it would kind of take you up to the high partial if you were kind of getting towards the answer but didn't fully get there. In the bullet points that they have there, they're kind of talking about different methods than I did in the question. So they're saying if you treated the equation, you subbed in x or y as any values, as the equation would have passed anywhere on the x and y axis, you could have subbed in any value for x or any value for y, and you would have found the corresponding coordinate for that on the line. That was using this method here that I'll just highlight. And you can see there, they're just mentioning that you can basically sub in any value for x and y. So that's what I was talking about. There's an infinite amount of answers that you could have given for this question. But good to see all the different methods that there are. There isn't just one right or wrong answer. Here at the very end, they use their slope formula and put it equal to the slope 4 over 1. So lots of different ways. It really depends on yourself what way you interpret the question and you want to answer it. As I said, I found the first way that I did on the previous page the easiest of all. The final exam question that we will look at today is from the SEC sample paper. The question on coordinate geometry here tells us that we have a triangle ABC and they give us the coordinates of point A, which is 4, 2. And just like the last 2 exam questions we looked at, they firstly ask us to find out what are the coordinates of the point B and C. So just like before, we need to figure out where does the point B and C lie on the x-axis and on the y-axis. So starting with point B, we can see that the point is on the x-axis. Therefore, if it's on the x-axis, that means that y must be equals to 0. So we can see it's 8 on the x-axis and 0 on the y-axis. C, on the other hand, is 10 on the x-axis and 4 on the y-axis, giving us the coordinate 10, 4. So again, just like the last 2 exam questions, part A, very easy, just asking us to find out what the coordinates are from the diagram. Part B of this question says the table below shows the equations of the line AC and AB. Work out the value of M and the value of K in each of the equations. So we can see firstly in line AC, it gives us the equation y equals mx plus 2 over 3. So they want us to find out what is the value of m here. So they have written that equation in the format y equals mx plus c. So we should know from using this formula again that the m there represents what the slope of the line is. So there's a few different ways that you could do this, but looking at our diagram, we can work out what my slope is going from A to C. So looking at point A here and looking at point C, I could use those 2 points and figure out, okay, if I did my slope formula here with point A and point C, I would figure out what the slope is. Or we could just use our diagram and figure out what is the rise over the run. So as I travel from A to C, how far do I run over and how far do I rise? So the run goes horizontally across from A over to C. So I start at point 4 and I finish at 10, which gives me a run of 6. And then I rise from A to C, going from 2 to 4, which gives me a rise of 2. That means that the slope of this line is equals to 2 over 6, or it can be simplified to 1 over 3. So that gives me that m is equals to 1 over 3 in that equation. Likewise, in the equation for the line AB, it is written in the form y equals mx plus c. This time, the missing value k is in the c position. The plus c represents the y-intercept, so it's when the line AB will cross the y-axis. Again, we can use the rise over the run for this. So if we look at what the slope of AB is, we can see that as we move from A to B, our rise goes down, which means we will have a negative slope, and our run goes across. So the rise there goes from 2 down to 0, which gives me minus 2, and the run goes from 4 to 8, which gives me a run of 4. That slope will continue if this line was to continue on. So going from point A, I can see that if I run over 4, which will take me from 4 on my x-axis back to 0, and run up 2, that line would continue on going up to this coordinate here, which means that the y-intercept is at the point 0, 4. That indicates that the c value here will be plus 4. So c is equals to plus 4, which means that k is equals to 4 in my equation. So finishing off this question, we found out that m was equals to 1 over 3 in my first question, and k was equals to 4 in my second equation. And we used our slope formula rise over run to help us in the diagram here. And that concludes today's lesson on coordinate geometry of the line. We looked at the 2023 exam questions, 2022 exam questions, and the exam questions from the SEC sample. Looking at those questions, I hope you can see it's really important that you make good use of your formula booklet in these questions. Make sure you know what formulas are there in your formula booklet and the different ways that they may ask you these questions. These questions allow you to pick up some easy marks, and I hope that you can see that from my answers today. So I hope you enjoyed today's lesson and you got good value out of it. See you soon.